Back in April, we reported on some very surprising results from NASA's Messenger spacecraft, as it ended its mission by crashing into Mercury. Messenger had been watching Mercury's exosphere for years, and in the last few days of its life, it saw something incredible. It was a sudden release of metals into Mercury's exosphere, and that raised a lot of questions. We don't really know why this happened. So today, scientists are publishing an article that takes a closer look at these final observations and tries to figure out what was going on. First, let's recap what we know. Mercury doesn't have an atmosphere in the traditional sense. There isn't a thick layer of gas around the planet. It's like we have here on Earth. But there are times when bits of rock and dust get kicked up off the surface and form a thin, tenuous layer of gas called an exosphere. When Messenger began orbiting Mercury back in 2011, it found that the exosphere was full of sodium and potassium, both of which are only found on the sun-facing side of the planet. That makes sense because they both came from the crust of Mercury, which is covered with a layer of frozen volatiles on the far side where it's always in shadow. Those materials can sublimate, meaning they go directly from solid to gas without melting. And the sun shining on the near side can then blow them into space. But Messenger also found a whole bunch of hydrogen on the dark side of Mercury. And that was weird, because it shouldn't be able to get there. You see, the solar wind, which is a stream of charged particles constantly flowing away from the sun, is really good at stripping hydrogen off of things. So if hydrogen was coming from Mercury's crust, it would get stripped away before it ever made it to the dark side. The only way it could exist over there is if it was coming from somewhere else. In 2014, Messenger discovered that it was coming from the magnetotail of the planet Jupiter. Mercury is tightly locked to the sun, so one side is permanently illuminated, while the other remains in darkness. But Mercury does have a magnetic field. It's very weak compared to Earth's, and it's not a dipole like ours. It's more like a tilted wall. That means Mercury has a magnetotail, just like Earth's, a region of space dominated by the solar wind on the side opposite the sun. Messenger found that the hydrogen in Mercury's magnetotail had a peculiar distribution. There were a few clumps that looked like they were sitting on the surface of Mercury's crust, but most of it seemed to be floating in a thin sheet about 600 kilometers above the surface. What's more, the hydrogen atoms had a very particular direction of motion. They all seemed to be moving away from the sun, which is odd because the solar wind is blowing in that direction too. And the solar wind should have blown the hydrogen back towards Mercury. Something was slowing them down and even turning some of them around. That was weird enough on its own, but it got weirder. In 2015, Messenger noticed a sudden increase in the amount of hydrogen on the sunlit side of Mercury. All of a sudden, instead of being mostly confined to the magnetotail, hydrogen atoms were escaping off Mercury's near side. This caught the team completely off guard. It expected any increase in atmospheric mass to be pretty evenly distributed over the planet. But the change they saw was extremely localized, coming from a single hemisphere and only lasting for a few hours. To make matters even weirder, the hydrogen didn't stop at the edge of Mercury. Normally, if a bunch of stuff builds up on one side of a planet, gravity will eventually drag it down to the equator, or it'll just spread out until the planet's gravity pulls it back in. But that didn't happen. The hydrogen just kept going and eventually disappeared. It was literally lifted up off Mercury's surface and released into space. At first, the team thought it might have come from an impactor, some small asteroid that slammed into Mercury and blasted a bunch of stuff into the atmosphere. But Mercury is tightly held by the gravitational forces of the Sun and Jupiter. Any small body trying to approach it would be torn apart long before it got close. So whatever caused this release, it couldn't have come from something outside of Mercury. It had to come from the planet itself. The authors suspected that it was a release of volatile materials from the interior of Mercury. Similar to how water and CO2 are released from Earth's mantle through volcanic activity. But on Mercury, it probably wasn't coming from volcanoes. Mercury is so small that it probably cooled off long ago in any internal heat. It has left as slowly leaking out through a process called conduction. If there's a temperature difference between the inside and the outside of a body, heat will flow from the hot part to the cold part. In Mercury's case, the sun-facing side is hot enough to transfer heat quickly enough to drive out volatiles. But it doesn't work on the dark side because it's so much colder. Unfortunately, Messenger's instruments weren't designed to detect things like volcanic activity, so it couldn't tell if that's what was happening. But it did have one more trick. Back in April of 2015, Messenger began its descent into Mercury's orbit. Rather than firing its thrusters to slow down and crash into the planet, the team decided to leave it on a trajectory that would take it straight into the sun. By doing so, they could use Messenger's own instruments to measure the density of the exosphere one last time, giving them one last glimpse of Mercury's weird atmosphere. And what they found was shocking. Over the course of just a few days, the density of Mercury's exosphere jumped by a factor of 10. Then it dropped again after Messenger flew through it. It was over almost as soon as it started, and it happened right at the end of Mercury's orbit, when the planet was on the opposite side of the sun from where the release had happened the year before. It was another release of material from Mercury's surface, but this time it was happening on the far side where it was cold enough to hold on to volatile materials. But the team still doesn't know exactly what happened. One possibility is that the two releases were connected. Maybe there was some kind of global event that caused volatiles to bubble up from deep within Mercury's interior and escape through the cracks in the crust. Or maybe they're unrelated, and just two examples of the same process happening at different spots on the planet. More data is needed to say for sure. We know that Mercury has cooled off enough that it's releasing volatiles from its interior. But we don't know if it's still cooling, or if this is just how it's going to be from now on. If it continues to cool, we might see more and more of these releases, which would help us understand what's happening beneath Mercury's surface. The Messenger team is eager to get back to work analyzing their data, but unfortunately, they've been furloughed due to the U.S. government shutdown. Government funding runs out on January, so they're working as fast as they can to get this paper published before their funding runs out. And once they get it published, they'll have to wait until the government opens back up so they can analyze more data. This is a classic example of how planetary science works. We make an exciting discovery, then we have to wait years to collect enough data to understand it, and we have to wait even longer for the government to give us permission to analyze it. But sometimes the payoff is worth it, like when we discovered evidence of liquid water on Mars, or when we found organic molecules in a meteorite from Saturn's moon Titan. We don't know what secrets Mercury is hiding, but with missions like Messenger, Bepi-Colombo, and the upcoming European Solar Orbiter, we'll keep learning more about our smallest planet. Thanks for watching this episode. If you liked it, do a quick favor for us. Click the thumbs up button. It helps us get more eyeballs on our science news, so we can keep making videos like this one. And if you want to support us even further, you can become a patron on our support page. And as a special thank you, we have a zine for our top-tier patrons. Zines are those cool handmade magazines that people used to make before the internet was invented. They're full of fun facts and behind-the-scenes stories about our show. Our next one will be about the making of our video on black holes. You can get this one and all of our past zines if you sign up before January. So thanks for watching, and we'll see you next time.